Good morning. The work that I'd like to share with you today started with a question. If I show you a page of piano sheet music, can you predict the composer? The input is a scanned sheet music image, and the output is the predicted composer. We treat this as a classification task using a fixed set of K composers. Our approach is based on two key ideas. The first idea is that we should use as much data as possible. In our experiments, we use all piano scores in IMSLP. The second key idea is to utilize unlabeled data through language model pre-training. Our approach has 4 key steps shown in this figure. We'll walk through each of these steps in the next 4 slides. The first key step is to extract a bootleg score. The bootleg score is a low-dimensional feature representation that encodes the positions of note heads in the sheet music. It is a 62 by n binary matrix where 62 indicates the number of different staff line locations, and n indicates the total number of simultaneous note events. The second step is to tokenize the bootleg score. We work with both word-based language models and subword-based language models. For word-based language models, we encode each column of the bootleg score as a 64-bit integer. This serves as a word ID. For subword-based language models, we interpret each column of the bootleg score as a sequence of 8 bytes. Each byte acts like a character. We can then apply a byte pair encoding algorithm to learn a vocabulary of subwords in an unsupervised manner. At the end of this second step, we have a sequence of words or subwords. The third step is to take a sequence of words or subwords and to sample fragments of length L. This has 2 key benefits. The first is that we can significantly augment the data. And the second is that we can sample the data in a way that leads to balanced classes. The last step is to train the classifier. We consider 3 different pre-training conditions and 3 different language model architectures. The first 2 pre-training conditions shown in this table only utilize the labeled data. The third condition first pre-trains a language model on the unlabeled data and then fine-tunes on the labeled dataset. During test time, we take all of the fragments from a single page of sheet music and average their predictions in order to generate a single prediction for the composer of that page. For our experiments, we hand-labeled 7,000 pages from 9 different composers, and our unlabeled dataset contains all piano scores in IMSLP. These are our results. There are 2 things that I'd like you to notice. The first is that pre-training helps a lot. Within each group of histogram bars, you can see that the performance increases a lot as you go from the green bar to the blue bar to the red bar. This indicates that pre-training makes a big difference. The second thing to notice is that the best model is the GPT-2 model. And in general, the transformer-based architectures perform the best. The main thing that I'd like you to take away from this presentation is that by converting sheet music into words, we can apply powerful techniques from the NLP community. Thanks for your attention, and I look forward to talking with you at the poster session.